beautiful people, and welcome. In this video, we're going to be going through the questions that you're going to see on your quiz on Module 5 in Integrated Math 3. As always, if I make a mistake, let me know. We both can learn from my mistakes, so you don't have to make your own. Let's go ahead and get started. Now, I do have the pre-quiz here in front of me. I'm going to set it aside so that way if I need extra room, I have some. And then maybe on some of the graphing questions, I'll go back to the actual sheet. Now, number 1 says, describe the transformations necessary to transform the graph f of x into g of x. So whenever you see describe the transformations, what that means is translate the math into English. For example, they give us f of x is equal to x cubed, and then we have g of x is equal to 3 times x minus 2 cubed. So this here is our parent function. And then this here is our transformed. Okay, so notice that in the transform, there will be some characteristics of the parent. So we do have a bubble. Let's go ahead and point out the bubble. And then we have this exponent of 3. Notice that the exponent of 3 came from the parent and the bubble came from the parent. However, we are mathematicians and mathematicians are lazy. So there is a bubble here. We just don't see it. And if you're not in my class, a bubble means parentheses. It means grouping. So the bubble and the 3 came from the bubble, and the 3 in the exponent came from the parent function. So what else happened? We're just going to translate everything that we have. My recommendation is start circling everything that is not x and not the exponent. So we have two things in this example. This one is outside the bubble, so that means it is vertical. It is being multiplied, so we are vertically stretching by a factor of 3. Second one is inside the bubble, and we are subtracting. Anytime that things are inside the bubble, we're talking about horizontal. And anytime it's inside the bubble, we do the opposite. So if we are minus 2, in fact, I'm not really minusing 2, I'm adding 2. So I'm going to the right 2 jumps. You can say horizontal shift 2 to the right. So horizontal shift 2 to the right. I kind of wrote that backwards, but that's okay. So horizontal shift 2 to the right. That's it. That's your translation. The bubble and the exponent, that just comes from the parent function. All right, let's do number 2. Transform the given functions as described. So this one here, I'm going to go back to the original. So this one we already did. Given the parent function, what would the equation be with the following transformation? So here's your parent function. So again, we're going to keep the characteristics of the parent function. So the parent function that we have has an absolute value. The absolute value will be treated like our bubble. Okay, it's our grouping. So compress vertically. Vertically is outside the bubble. Compress means that it's getting smaller, and it also means that you're going to multiply. So you're going to multiply outside the bubble by a factor of 3. Now be careful, because if we are going to be compressing, okay, if we're going to be compressing, then it's outside the bubble, we kind of have to do the opposite. So if we're compressing by a factor of 3, it's actually a 1/3 that I have here. Okay. So then we have, because it's a compression. Compression outside of the bubble means you're going to have a fraction. Okay, by a factor of 3, translate up 2 units. So up, we are going vertical. Vertical means outside the bubble. So that means my bubble stays like this. So it stays pretty much identical to the parent. And then I'm going to go up 2 units on my transformation. And again, what is this equal to? Let's call this g of x. Okay, the reason again I didn't multiply by 3 because it is outside the bubble. If I choose to multiply by 3, that will indicate a stretch because it is greater than 1. So if it's a compression, it needs to be a fraction. All right, number 3, state if the given functions are inverses. I'm going to use the other sheet of paper for this. So state if the given functions are inverses, we have to use composition of functions. So here is g of x. Kind of made my cube root a little big, but that's okay. So here's the thing. What's the opposite of cubing something? You take the cube root. What's the opposite of cube root? You cube it. So I am hopeful that these are going to be, in fact, inverses, but I don't know for sure. So when you're doing inverses, you have 2 things to prove. The first thing you have to prove that f of g of x is equal to x. And you have to prove that g of f of x is equal to x. Yes, there are other ways to prove it, but this is the method that we're using. If you choose to use any other method, I will be marking it incorrect because you're not reading the directions. All right, let's go ahead and get started on this one. Start with f of g of x. Step number 1 is to write out what f of x is. But we don't have x, we have g of x. So what you're going to do is keep everything else the same, but I'm going to put a bubble inside my parentheses here to indicate what g of x is. And g of x, and you know what? That is not enough room for me, so let me go ahead and scratch this out and make it bigger. Okay, so let's change that to pencil, and hopefully you guys can see pencil. All right, this is what I have originally. So I'm going to just shift it here. So here's my original parentheses. Here's my minus 2. Here's my cube. Now inside of this is where I'm going to put my g of x in place of the x from f. So this one here, I'm going to put that in a bubble. So then what goes in here? Cube root plus 2. And I am very hopeful because look at this, you guys. This says I have a cube root of x plus 2 minus 2. Well, plus 2 minus 2, those are opposites, so those go away. So then I'm left with a cube root. Ooh, we're doing all sorts of mistakes today. Cube root of x cubed. So if you have a 3 as the root and then you have a 3 as the exponent, they undo each other, so you're just left with x. So f of g of x, let me write that there, is in fact equal to x. Now, that's only half of the problem. Now we have to do g of f of x. And we're doing the opposite. So now I'm writing the g of x. And instead of writing x now, I'm going to copy everything else down. But in place of x, now I'm going to put my f of x in there. So what is f of x? F of x is x minus 2 cubed. This bubble is cubed. It's also cube rooted, so that goes away. So I have x minus 2 plus 2. Those 2 cancel out. And again, happy dance doing here because that means I have x left over. So g of f of x is equal to x. Both of them equal to x, so yes, they are inverses. Question number 4 is asking us to find the inverse of each function. Sorry about that. Find the inverse of each function. That's what are we doing? 4. Question number 4. So g of x is equal to 5th root of x plus 1 plus 1. And we want to find the inverse of that. So step number 1 to find the inverse, you're going to switch out g of x to y. Keep everything else the same. Then after that, you're going to switch the position of x and y. So now we have x is equal to the fifth root of y plus 1 plus 1. So now we're going to solve for new y. This one here we switched x and y. And here we wrote g of x as y. All right, so here we go, solve for new y. What do I need to do? I need to get y by itself. Y is inside, so that means it does have a bubble in here. We just can't see it. This bubble is being fifth rooted, and then also there's a plus 1 on the outside. So deal with it, everything on the outside first. So I'm going to subtract 1. So if x minus 1 is equal to the fifth root of y plus 1. So how do I undo the fifth root? I'm going to take all of what I have, and I'm going to just take the exponent of 5. That doesn't seem right, English. Sorry, guys. I'm going to fifth it, right? If I'm going to square something, I'm going to take it the exponent of 3, exponent of 5. I don't know why it's not coming out properly. I apologize for that. We're going to have the exponent of 5. And the reason for that is we have the exponent of 5. We have the root of 5. So that goes away. So I'm left over with y plus 1 is equal to x minus 1. Now make sure x minus 1 is in a bubble because the exponent of 5 applies to both terms here. Now this doesn't mean x to the 5th power minus 1 to the 5th power. That is no. So you just have this bubble 5 times. Okay, now I'm going to subtract 1. So I have y is equal to x minus 1 to the 5th power minus 1 as my inverse. Now, this is not your answer. You need to make sure that you are rewriting y as the inverse function notation. So the inverse function of, not of g, it's the inverse function, not an f, but of g, of x, is all of this goodness. All right, let's go back to the original. It says, sketch the graph of each function. So in this one here, we're sketching a graph of a cubic. Here's your cubic. We know that it's a cubic because the exponent is 3, so it's going to look like Mr. John Travolta. So we're going to have either something like this or something like this. This one is increasing. This one is decreasing. You can see that it's going downhill. This one's going uphill. So how do we know which one's increasing or decreasing? You can look at the exponent in the front. We've already graphed polynomials, so you know if a is positive, it's going to be increasing. If a is negative, then you're going to decrease. You can use transformations here and note the original reference points, and the reference points for a cubic are 1, 1, 0, 1, and negative 1, 0, 0, and negative 1, negative 1. So I'm going to sketch the parent. The parent function is saying 1, 1, 0, 0, negative 1. So that's the parent function. Now we need to do some transformations and graph this one here. Now it is your choice what you want to do. You can plug and chug, but if you choose to plug and chug, then you have to make sure that you take really good values for x. For example, if you want this right here, this bubble to be, I want this bubble to be 1, that means my x has to be 3. So if x new is 3, 3 minus 2 is 1, 1 cubed is still 1, 1 minus 3 is 2. So again, what's another value that's pretty? 0 is pretty. I want this bubble to be 0. I'm going to add 2 to both sides. So I have x is equal to 2. So if I plug in 2 here, 2 minus 2 is 0. 0 cubed is 0. 0 minus 3 is negative 3. Okay, let's do one more. Let's say I want this bubble to be now negative 1. I'm going to add 2, add 2. So x is equal to, what is this, 1? Oh, this should be 3. No, this is right. So if I have 1 in here, I plug in 1. 1 minus 2 is negative 1. Negative 1 cubed is still negative 1. And then so I have negative 4 as my output. Now taking these points right here, let me zoom back out. There you go. Taking these new points here, I'm going to graph it. So 3, 2, 2, negative 3, negative 1, negative 4. And something doesn't seem right. So it should match the exact same shape. So hopefully you guys can see my mistake. It should match this shape. So let's say our vertex. Let's double check our vertex. Vertex is h comma k. So vertex is the opposite of what you see. So it's 2, negative 3. So our vertex is 2, negative 3. So 2, 1, 2, negative 3. That's good. Now let's double check. If I input 3, 3 minus 2 is 1. 1 cubed. Oh, this should be negative. Do you guys see that? 3 minus 2 cubed minus 3. This is 1 cubed. Excuse me, cubed minus 3. So 1 minus 3 is negative 2. So this should have been negative 2. Let's go ahead and change that. So this is 3, negative 2, 3, 1, 2. And then negative 1 and 4. Still doesn't seem right now. Am I doing all of my math correctly, you guys? Hopefully you're yelling at me at the screen. Let's double check our math. In my defense, it is like 6 o'clock in the morning. Okay, let's double check some math. If I plugged in 3 minus 2 cubed minus 3, 3 minus 2 is 1, 1 cubed minus 3, 1 minus 3 is negative 2. So my input is, what was my input? 3. My output is negative 2. That one's fine. Let's try another one. We already checked our vertex, so let's try negative 1 minus 2 minus 3. Oh, that's probably why. It shouldn't be negative 1. It should be positive 1. Positive 1. Because, you guys, if I go back here, we had positive 1. And for some reason, I took that positive 1 and I made it negative here. So that was what was the issue. Because I want this bubble to equal negative 1. So negative 1 cubed minus 3. Negative 1 cubed is negative 1 minus 3. That's negative 4. So then my other point is positive 1. My input is positive 1. My output is negative 4. So let's go ahead and change that. This is a positive. So positive 1, negative 4, there it is. Now we can continue by sketching out what our parent looks like. So this is the original, this is the parent, and this is the transformed cubic function. Sorry about the hiccup, you guys. All right, let's move on to number 6. Number 6 is write an equation for the given function. Step number 1 is you need to identify your pretty points. Your vertex is definitely one of them. So here's your vertex. Here's one pretty point. Here's another pretty point. Your format is f of x is equal to a x minus h cubed plus k. Vertex is h comma k. So again, it's h is always the opposite of what you see. So what is our vertex? We have negative 1 and 2. That's our vertex. So inside our equation, now I'm doing positive 1 because it's opposite. But then k is whatever you have. So if it's positive, it remains positive. Okay? So once we have our vertex, then we just figure out what a is. A is you choose whatever point you want to. That's not the vertex, and you solve for a. Let's do this. So I have y is equal to a times x plus 1 cubed plus 2. I'm going to choose this point here just because it has a 0. So that means 0, 3 is the point I choose. That means this is x, this is y. So y is 3, x is 0. So that means I have a times 1 cubed plus 2. So 3 is equal to, what is this, 1? So this is a plus 2. I'm going to subtract 2 to both sides. So I have a is equal to 3 minus 2 is 1. So I have a is 1. So now for my final answer, do we really need to write a? Not really, because it's just 1. So my final answer is going to look like f of x is equal to x plus 1, x plus 1 cubed, plus 2 as my final answer for the equation of the function given. All right, this one here, sketch the graph of the given polynomial function. All right, let's do these. I think these are personally really fun. So we have to do the leading coefficient, total degree of the function. Total degrees, just take all of your exponents, seen and unseen, add them up. So 3, 4, 5, 6, 7, 8, 9, 10. That means it is even. That means we're either going to have up and up, or we're going to have down and down as our end behavior. So leading coefficient is -3, so that means it is negative. So that means that we're not going to be increasing, so our end behavior, as x approaches infinity, y approaches negative infinity, and as x approaches negative infinity, y approaches negative infinity. Now, here's the thing, you guys. If your teacher wants you to write this, do it. I'm okay for end behavior doing right and left. The right goes down, the left goes down. For graphing polynomials, I'm okay with this type of end behavior, unless it specifies this. Okay, so we have our end behavior. Now we need to identify our x-intercepts. Anytime you see an x, you're going to draw an arrow. And so then what does x have to be in order for this to be 0? This is 0. Anytime you have a singular x, that it doesn't have like a bubble like this, it's always going to be 0. So I have 0, I have 1, I have -5, and I have 8. So that means my x-intercepts I have 0, 0, I have 1, 0, I have -5, 0, and I have 8, 0. And so then what is the behavior of each? For the behavior, you're looking at the exponent. So for this one here, it is a 2, which is even. Even means we have a parabola. So we're either going to have something like this or something like this, but we're not going to cross the x-axis. We're just going to kiss it. This one here is an even as well. So same thing, we're going to have a parabola, either like that or like that on our x-axis. Then we have a -5, which is 1, which is linear. Then we have a 3, which is odd. Odd is a John Travolta, so we're going to have either something like this or something like that. Linear is just a line. And that's it. So let's go ahead and graph. Start out by sketching out your intercepts. So I have an intercept at 0, 0. I have 1, 0. I have -5, 0. And I have +8, 0. Our end behavior is going to be down and down. So we're going to do the most left and most right point, down and down. Then we're going to sketch what the behavior is. So at -5, my behavior is linear. We're going to have a line. So line goes straight through. Then we're going to have at 0, we're going to have even. So we're going to have a parabola. So that means when I go to touch 0, I'm not actually crossing. I'm going to go back up. And at 1, I have also. So that means I'm going to go something like this here. Let me see if I can get rid of this line because I thought we were going to go somewhere further. So here's my parabola at 0. And then I'm going to have a parabola at 1 as well. So there's a little hump there. And then at 8, we're going to go on. So we're either going to have this one or that one. Well, I need it to go through and connect. Okay, so I need it to go through and connect. So we're going to have it be as such. And it doesn't have to be perfect. You guys are not, human computers. So something like this, as long as your end behaviors are correct, I'm going to be looking for end behaviors. I'm going to be looking for X-intercepts. I'm going to be looking for behavior at each 0. Those are the things that I'm going to be looking at. Go ahead and do this one here. This one's going to be the last one for this video. The other questions are very similar, so I'm going to hold off on those. So write the equation for the given polynomial. So we're doing the opposite. Step number 1, you're going to create 3 columns. First column is your X-intercept. Second column is you're going to do the opposite bubble, and which is X, and then something next to it. And then you're going to do behavior for your zeros. And that's going to give you your exponent. All right, let's do that. Identify your zeros. So I have -5, 0. I have -3, 0. I have 0, 0. And I have 4, 5, 6, 0. Now we're doing the opposite bubble. So X plus 5, X plus 3, X plus 0. Again, that's just X. And then we have X minus 6. We're doing the opposite of each bubble. So now we're going to say, hey, what was the behavior at each 0 to find out what our exponent is going to be. So at -5, I see a line. So the exponent is going to be 1. At -3, I see that it doesn't go through, that it's only touching the x-axis. It doesn't actually go through the x-axis. That means it's even. And remember, you guys, this is going to be the degree, the parabola of the least degree. So your options are 1, 2, or 3 only. Those are your only options for exponents. This one here, notice that it has a curve. So if it has a curve like that, it is odd. So it means we have a Mr. John Travolta, which is 3. And then we have a line again, which is 1. After that, you are done. Double check. This is an odd function because we have left and right hand side going opposite. So all of your exponents needs to add up to an odd number. 2, 3, 4, 5, 6, 7. 7 is odd. Okay. So then we're going to say, what is this? We're going to write this out. We still don't know A, so we're going to leave it. So now we have all our bubbles and our exponents. So X plus 5 is 1. X plus 3 is 2. Just X is 3. And we have X minus 6 as 1. So I went ahead and copied this down here on a separate sheet of paper so you guys can see it. Next up is A. So a lot of times what they're going to tell you is assume A is -1 or 1. That's the easiest part. You don't actually have to figure out what A is. I'm going to try to see if I can give you these questions. If A is not -1 or 1, you're actually going to have to take a point that is not one of your X-intercepts. You have to take a different point and then plug it in. But they have to tell you what that point is because this is all just, kind of random. So we're going to assume A is -1 or 1. So we know this is an odd function because left and right hand are different. Now notice that left hand is up, right hand is down. That means we have a decreasing function. Anytime we have a decreasing function, our A value is negative. So what is our final answer? Our final answer is negative. Order your exponent from highest to lowest, except if you have a singular x that goes in the front. So x cubed times x plus 3 squared times x plus 5 times x minus 6. Double check that you have everything, you haven't forgotten anything, and that is your answer. All right, beautiful people, thank you so much for watching. I tried to make this video shorter. I don't think that actually happened, so I apologize. But enjoy the rest of your day, and I will see you in the next video. Bye.